Okay, so in this next video I'm going over geometry and measurement. And again, I'm not doing all of the standards in geometry and measurement, just the ones that are critical concepts, ones that I am guessing are most likely to show up on the actual ISTEP. And again, these problems came from the Indiana Department of Education's website, and I'm just kind of going over some of these problems that they've already given to us. All right, so in this first question for part A, it says define and describe the attributes of right rectangular prisms, cylinders, cones, spheres, and pyramids. Notice that they're right rectangular, or so we're looking at pyramids that are not going to be, or prisms, cylinders that are not going to be tilted. They're all going to be, the bases and the sides are going to be have right angles. So a couple of things that, okay, so this is my word bank here. I'm trying to remember what I did here. So a right rectangular prism, so I've already got it kind of worked out here. I'm just having you fill in the blanks with what these words are. So a right rectangular prism is a prism with two what kind of bases? Well, if it's a right rectangular prism, then it's going to be a rectangular base. I guess I didn't put that in the word bank. Okay, so I forgot that. Prism with two rectangular bases, in which the angles between the bases and sides are perpendicular angles. So again, the easiest way to think of a right rectangular prism is a box. Think of a shoe box. That is a right rectangular prism. So the next word is a cylinder, a right cylinder. So a cylinder with two, if you think of a cylinder is like a soup can. You're going to have circles at the top and the bottom. So there are two circular bases, and the axis between the center of each base is perpendicular to the bases. So thinking of this, looking at this cylinder here, so if I were to put an axis between the center of each of the circles on the top and the bottom, it would be perpendicular to the circle, which is both of the circles, which are your bases. Okay, a right cone. So a right cone is a cone with one circular base whose center is perpendicular to the apex, which is the top vertex of the cone. So I don't necessarily have a picture of a cone right offhand to show you. So if I were to draw a cone, it would three-dimensionally, I would draw like an oval and a point here at the top. So if it's a right cone, what this is saying is that if we were to draw, it's going to have a circular base, and the segment, if I were to draw the segment from the top here, the apex, to the center of our circle, that would be perpendicular to the base. So that's what makes it a right cone. A sphere. A sphere is basically think of a ball. So it's a 3D solid where every point on its surface is equidistant from the center. So if you think about a sphere and you think about the center of a sphere, if I were to pick any point on this sphere, the center of the sphere to any point anywhere else on the sphere is going to be the same distance away from the center. So all of those would be what we would call a radius. A right pyramid. So here's an example of a right pyramid. a right pyramid, it's a pyramid with an apex. So again, the tip of this pyramid to the center of our base would be perpendicular with the base. So a pyramid with an apex perpendicular to the center of one base. So there's only one base in a pyramid rather than two. All right, so those are some of the definitions and things to kind of get you familiar with the different types of three-dimensional figures that you might that you need to know. All right, in letter B, it says a dotted line below represents the slicing of a sphere, a square pyramid, and a cylinder. So these are our three shapes. Describe the two-dimensional shapes. So the two-dimensional shapes are basically what we call cross-sections that result from each slice. Describe other ways to slice the figures and the resulting two-dimensional shapes. All right, so with the sphere, if we were to slice it, think of a sword cutting it through, or a plane cutting through the circle or the sphere right through the center. What would this two-dimensional shape be? Well, I know it's hard to see three-dimensionally, but if you were to cut that in half and look at the halves from the center, it would be a circle. So the cross section here would be a circle. And really, no matter where you cut or slice a sphere, you're always going to get a circle. The next one, the right pyramid, if you were to slice it, it looks like it's sliced parallel to the base. So if we were to kind of show that slicing, that cross section there would be a rectangle or whatever this shape is. So it doesn't really tell us, well actually I think it does. It does tell us that it's a square pyramid. Okay, so since it's a square pyramid, all four of these sides would be the same. So as long as this plane is cutting through the center and it's parallel to the base, then that cross section would also be. So if I was to cut that open and look at it from the front, it would be a square. And all four sides would be congruent, and all the angles would be congruent also with a square. Here's another example of a cylinder. So if you were to slice a cylinder and look at its cross section or two-dimensional shape, again it would be, so this here was your square, this here would be a circle. All right, so those are the cross sections we would get from the lines that they gave us. But are there other ways that you could slice this figure? Well, yes. So what if we, instead of slicing it horizontally, we sliced this vertically? So if we had a plane that we were slicing vertically and we cut this in half this way, we would actually have a cross section that would be a rectangle. So again, if I were to slice this from the top down and then open it up and look at the center of it, look at the two-dimensional shape that's formed, it would be a rectangle. If we were to slice this pyramid, so, or a cone, let me do a cone, because a cone is kind of easier to see. So if I were to slice this cone from the top down, right across the diameter, then the cross section would be a triangle. So again, it's hard to see a three-dimensional, try to see the two-dimensional shapes that are formed from three-dimensional objects, but there's some really great YouTube videos out there that show some better examples and better demonstrations of cross sections. So these are called cross sections of three-dimensional objects or solids. So if you just look up cross sections of three-dimensional solids, you can see some really cool videos about that. All right. In problem C here, we're supposed to classify the figure, then describe the features that led you to that decision. Okay, so one thing we're looking at is how many bases it has. So if it only has one base and all of the edges are then coming up to a point, this is a pyramid. So a pyramid has only one base and then has triangles around it. Those are some of the features of a pyramid. So this is going to be a pyramid. But what type of pyramid? This pyramid was a square pyramid because the base was a square. Well, what shape is the base here? Well, we've got to count the sides. So if I count 1, 2, 3, 4, 5, 6, there are 6 sides to my base. So something with 6 sides is a hexagon. So we would say a hexagonal pyramid. Again, hexagonal because it's 6 sides. 6-sided base. So that's my classifying, and to describe the features, it has one base that is a hexagon, and there are triangles all around. The lateral sides are the lateral surfaces are all triangles. All right, and the last one here in the geometry, I think this is, nope, we got more geometry. Okay, so what conic section is created by a diagram, in the diagram, by slicing the pentagonal prism? So we have a pentagonal prism, and they're showing us a slice straight down here. So it looks like it's kind of diagonal, yeah. So if we look at from here to, from this part of the two-dimensional shape to this one, and you compare it to this one, and then you go across here, it looks like we've got 2 parallel sides and then 2 sides that are a little bit, that are going out. So I am going to say that this is a trapezoid because it looks like these are parallel. Again, I can't tell for sure. We could also just say it's a quadrilateral to be safe. So a quadrilateral has 4 sides, but I'm guessing that the top and the bottom are going to be parallel. So if that is true, then it would be a trapezoid. All right, so that's another cross section there. The next problem that we have is from Standard 8 GM 8. So again, it's an 8th grade standard, geometry standard. It tells us that the height of a house is 30 feet, which is an important piece of information. The base of a 31-foot ladder is located 15 feet away from the base of the house. So, and it's leaning up against the side of the house. So you would probably want to, the best way to start out this problem is to draw a picture. So if this is the side of the house is 30 feet tall. So I'm guessing from here to here it's 30 feet. And then the ladder is 31 feet. So that would basically be my hypotenuse. And the bottom of the ladder is 15 feet away from the base of the house. And it's leaning up against the house. But where it's hitting the house, actually this probably shouldn't look so we're not really sure where this is hitting our 30-foot house. Okay, all we know is that this is 15 feet away from the base, so the bottom of the ladder is 15 feet away from the house, and the ladder itself is 31 feet. But we don't know how high the ladder is reaching. We know that from the top to the bottom of the house is 30 feet. But we don't know exactly where this ladder is reaching. So the question is, how far up the side of the house does the top of the ladder reach? So that's what we're trying to find. We're trying to figure out what this dimension is from here to here. So we have a typical right triangle. We're going to use Pythagorean theorem to figure out this side, where 31 is our hypotenuse, 15 is one of the legs, and we're trying to find the other. So your Pythagorean theorem says that a squared plus b squared equals c squared, and c is the hypotenuse. So I'm going to put 31 in the place of c, and the 15 I'm going to put in place of a. It doesn't really matter whether you plug it in for a or b. And I'm going to say that this side that I'm trying to find is b. So again, we're going to take my 15 squared, which I believe is 225, and then plus b squared equals 31 squared, which is 961. Then I'm going to solve by subtracting my 225 from the 961, which gives me 736, which may be a perfect square. It may not. So let me try taking the square root of that. And it gives me 27.129. So a problem like this, they would either probably tell you to round to a certain place value, or they would tell you to leave it in radical form. But I'm guessing that we would probably round this decimal. So I would say approximately 27.13 if I round to the hundredths place. So to answer the question, how far up the side of the house does the top of the ladder reach? So it reaches about 27 feet. Because 27.1 is pretty close to 27. So that would probably be a good answer. But again, read your directions, make sure that you're rounding correctly and looking at what they want you to round it to. Okay, the next problem, a bystander is standing 5 feet away from a 12-foot or 12 feet flagpole. Should probably say foot there. 12 foot, that's going to bother me, flagpole. What is the distance from the bystander to the top of the flagpole? All right, so again, a picture might help. So here we've got our flag, and here's our flagpole. So the flagpole itself is 12 feet. So this is 12 feet from here to here. And then you've got this bystander. So here's this person, and they are standing 5 feet away from the flagpole. So this here is 5 feet. And what they want to know is, what is the distance from the bystander to the top of the flagpole? So since they don't tell us the height of the person, I'm guessing that they want us to find this length here. So let me move my 12 to this side. So the 12 feet is from the top to the bottom, so that's our flagpole. They're 5 feet away, and we're trying to figure out how far the person is from the top of the flagpole. So we are basically looking for our hypotenuse. So again, we're going to use Pythagorean theorem because it's a right triangle, and you're given two sides and you have to find the third. So again, your Pythagorean theorem, a squared plus b squared equals c squared, but the two legs are given. So I'm going to call a5 plus 12 squared equals c squared. So 5 squared is 25, 12 squared is 144. When I add those together, I get 169 equals 12 squared, or c squared. So then when I take the square root of both sides, now normally when you solve a square root equation and you take the square root of both sides, you would get a positive and negative value. However, this is a distance or a length, so you're only going to use the positive. It would only make sense to have a positive answer. So the square root of 169 is 13. So to answer the question, we were using feet, so the bystander, what is the distance from the bystander to the top of the flagpole? I would say 13 feet would be your answer. All right. Last one, and then we'll be done with the geometry section. So if the hypotenuse of a triangle is 10 inches in length and a leg is 5 inches in length, what is the length of the unknown side? So again, draw yourself a right triangle. They're telling you it's a right triangle. They're telling you the hypotenuse of this triangle is 10 inches. So this is 10 inches on this side. And the leg, a leg, one of them, is 5 inches. So let's just say this is 5 inches. And they want to know what this third side is. So I'm going to just call that x. But you can call it whatever variable you'd like. So again, we're going to use Pythagorean theorem. A squared plus b squared equals c squared, and c is your hypotenuse. I'm going to call a 5, and then in place of b I'm going to put x, and then in place of c I'm going to put my 10. So 5 squared gives me 25, plus x squared equals 10 squared, which is 100. So when I subtract the 25 to both sides, I end up getting x squared equals 75, which is not my final answer yet. I want to find x. So we would have to, I keep messing up here. So again, we would have to take the square root of both sides of the equation. And again, if this was a regular quadratic equation and we took the square root of both sides of the equation, we would have a positive and negative solution. So, but because this is a length, we're not going to have a positive and negative solution. So again, I'm not clear exactly how they would want your answer. They may just have the option of square root of 75. But if the directions tell you to, so this would be an exact value. However, if they ask you to simplify the radical, then you would want to factor your square root of 75 into the square root of 25 times 3, because 25 is a perfect square and it's a factor of 75. And 25 times 3 does equal 75. And now we can take the square root of 25, which is 5, and then the square root of 3 cannot be simplified. So if they want an exact value, you could use either one of these. If they want a simplified radical, you'd have to use this one. So this is your simplified radical, which is another concept that might be on the ISTEP. Or they may just want you to round it to the nearest hundredth. So if we just take the square root of 75, it should be, another skill you might be asked is to estimate the square root. So if I think of a perfect square that's a little bit less than, a little bit more than 75, I'm thinking of, say, 81, which is a little bit more than, 81's 9 squared, and 64, which is a little bit less than 75. So if the square root of 64 is 8 and the square root of 81 is 9, then the square root of 75 should be somewhere between 8 and 9. So that might be another skill that you're going to be asked to find. But if you're allowed to use a calculator on this part and you're rounding it to the hundredth, we would have 8.66, or approximately 8.66, and again it would be inches. So again, it depends on what they want, what the directions tell you, and how they want you to write your answer. All right, so that is the end of the geometry lesson.